The way to figure these out without actually referring to that regular polygon chart, the easiest angle to figure out is the central angle. That's the one that goes kind of in the middle. And since there are 6 sides to a hexagon, there are 6 angles, 6 of these 60-degree angles. So you just take 360 because that's the distance around the entire circle. And if there are 6 different angles you have to split that 360 into, that's where you get the central angle of 60 degrees. And it turns out that the exterior angle, or the vertex angle, is, since its exterior angle here is the same as the central angle, and this angle in here is 60, then to figure out what the vertex angle is, just take 180 and subtract the central angle. Over here, 180, subtract the central angle. The central angle here is 36 degrees because we take 360 degrees and divide by the 10 angles that take us all the way around. So 144 per angle times 10, 1440. It's hard to tell. If you printed this out, you would see that at each vertex, and I'll do it here, there is just 1, 2, 3 shapes that come together. And those 3 shapes are the regular hexagons. Now, each one of the, right at the vertex, for each one of these hexagons, this angle here is called the vertex angle. Since they are all 3 regular hexagons, the 3 angles will all be the same. And it turns out that in a hexagon, this vertex angle is 120. So up here is the hexagon, and we figured out that this angle here was 120. So 3 of these angles are going to come together right here. 1, 2, and 3. So it says, first of all, determine the number of angles that come together at each vertex. If you select any vertex, this one, or this one, or this one, or this one, and every single time, if you go all the way around that vertex, you're going to hit 3 different shapes. So if you start here and go all the way around, hit the first shape, the second shape, and the third shape. So 3 angles come together, and all 3 of them are the vertex angles of the hexagon. Each one of them is 120 degrees each. So it says determine the number of angles that come together, 3, as well as the measures of these angles. Well, all 3 of those angles come from a regular hexagon in which the vertex angle is 120. So all 3 of them are 120. The perimeter is the distance around, so you can use these 2 formulas or just kind of deduce them in some other way. In a rectangle, these opposite sides are the same. And so you have 2 side 10s, and you have 2 side 6s. So 12 and 20 is 32. And that's centimeters. So be sure to include the unit when you write these. And the unit for perimeter is going to be different than the unit for area. So we have 6 centimeters times 10 centimeters. So that's 60, and then that's square centimeters. So the units are going to be different for the same problem, depending upon whether we're talking about perimeter or area. In order to find the perimeter and the area of this right triangle, you need to find x. And so you know 2 of the 3 sides, so you can use the Pythagorean theorem to find x, square the smallest side, and then square the other smallest side. When you add them together, you have to have the square of the hypotenuse. So solving this equation for x, might have to get your calculator out if you don't know these perfect squares. All right, then we're going to subtract 225 from both sides. 64. So x is equal to the square root of 64, which is 8. But you need to have this 8 because it serves as the perpendicular side to the base. So this is the height and 15 is the base. Units are in yards, so this must be 8 yards. So the perimeter would be 17 yards plus 15 yards plus 8 yards. 42 yards. And the area is 1/2 times the base, 15 yards, times the height, 8 yards. And that is 60 square yard. Yards times yards is yards squared. And for the circle, we have these nice formulas over here. We do know the radius. So the circumference is 2 pi r, and the r is 4.5 inches. And the circumference, or the area is pi r squared. And that's going to be in square inches. So circumference is the distance around. So it's like you're walking a length, and the area is in square inches. It's what it would be required to cover that entire circle. All right, so I'm going to use the decimal approximation here. 2 pi times 4.5, there's the circumference, and pi times 4.5 squared, and there's the area. So this is about 28.3 inches. I round to the nearest tenth because the one measurement we had was rounded to the nearest tenth. And this is 63.6 square inches. Okay, a circle has a circumference. Okay, so the circumference is equal to 2 pi r. And they're saying that 2 pi r is equal to 18 pi centimeters. Because of this first information, and because we know the formula for the circumference, we can solve this equation right here, and we can actually find the value of the radius. And once we find the value of the radius, we can then find the area using pi r squared. So the first thing we're going to do here is divide by pi, because each side has a pi, and that'll cancel those pi's out. And that will leave us with 2r equals 18. Divide by 2, so you can see r is equal to 9. The only unit here was centimeters. And so the radius is 9 centimeters. So there's our circle. If you want to check it, if you want to calculate the circumference, well, the circumference is 2 pi r, which is 2 pi times 9, which is 18 pi, which is what they said the circumference was up here. All right, and step number 2, once we have the area, then we can plug it into the area formula. And this was going to be square centimeters. So you can say 81 pi square centimeters, or if you punch it on your calculator, it's going to be 254 point, I'll just 469 square centimeters. And it asks for the area only, so there's the only answer to this one. Number 7, which is the better buy, an 8-inch diameter pizza. I'll draw it here. Cost $4. And then a 16-inch. Okay, so 16 would be about right there. So you have to draw a diameter about that size. So 16 inches. And this one costs $12. Which is the better buy, and why? Well, one strategy, it's the one that we used last time, is that if you can break it down to the cost per bite, then the pizza that has the cheapest cost per bite could be considered the best buy. Yeah. Cost per bite. So the unit on top is dollars, because we've got the dollars unit here. And the bite would be, well, this is let's say a flat pizza. Let's say that their heights are the same. So the unit we really have to focus on is maybe one, since the unit is an inch, the cost per 1 square inch. So 1 square inch is, I'm trying to draw this to scale here, is about this size here, 1 square inch. 1 inch by 1 inch is 1 square inch. And if you could cut pizza into that size right there, that would be like 1 bite. So the cost per bite would be the cost per 1 square inch. How many of these square inches are in each of those? So to answer this question, then we would calculate the area here and take the cost divided by the area. And then we would calculate the area here, take the cost divided by the area. And then we would reduce. And then the unit in the bottom would be square inches, the area unit, and the unit on the top is dollars. So dollars per square inch. Okay, now we just have to do the work. So the area is pi r squared. And since the diameter is 8 inches of this pizza, the radius is half of that, 4 inches. All right, it makes sense here to get rid of the pi, because we're going to break this down by pennies, and we don't want to have any pi's in the answer anyway. 16 pi, 50. 50 point, let's call it 265. That should be enough precision. And over here, since the diameter is equal to 16 inches, the radius is half of that, 8 inches. So the area is pi times 8 squared, and that's square inches. So that's 64 pi. As a decimal, when you plug that in, you get something close to 201.062. That's square inches. Okay, so we have the area of the first pizza and the cost. Now, one thing you could do, just kind of quick, is you could say, well, for the cost of the smaller pizzas to equal the larger pizza, since the smaller one is $4, if I buy 3 of these pizzas, it would cost me $12. And one of these pizzas would cost me $12. But if I multiply the area also by 3, I get about 150 square inches, whereas this one over here has 201 square inches. So you can see that this pizza is going to be the better buy, because for $12, you can get this much area. And for $12 over here, you would multiply by 3, and that would give you 150.796 square inches. So you get much more pizza with the big pizza than 3 of the smaller ones. All right, the other way that you could do it is like I said over here, just take the cost per bite. So over this one, if you take 4 and divide by the area, 50.265, and punch that into your calculator, it's going to be about 0.0796. So if we round it to right there, that's 0.08. So it's about 8 cents per square inch. So you can say about 8 cents per byte. Whereas this one over here, the cost per byte would equal the $12 divided by the 201. And that's equal to about 0.059683. Again, if we round to the nearest penny, this is in dollars per, this would be about 6 cents. Oops, per square inch. Now, if you compare 6 to 8, now this is what's costing you money, right? So the best buy would be the cheaper one over here. So there's a couple of ways that you can reason through this. It says the room has an area of 76 square meters, and all the units are in meters. That's good. What is the length across the back? Right, so we'll just call this B for back. Let's try to find B. Okay, well, I guess what I'll do is I'll try to figure out what this area is. Now I know that the whole area is 76 square meters, but I want to figure out the area using B, and then whatever I find as an expression, I'll set it equal to the 76 because I know 76 is also the area. All right, so this side over here is 8, and this side over here is 5. So that must mean this side here is 3 meters. Right? The area of this rectangle here is length, and I called that B, times width, which is 5. So B times 5. That's this area here. Don't know what B is, so I can't come up with a number. And then this one down here, I'll call this area 2. It's the rectangle, and the length is 7, and the width is 3. So 7 times 3, 21 square meters. So the area of the whole thing is the sum of the areas A1 plus A2. A1 is 5 times B. A lot of times we'll just write that 5B. And the area of A2 is 21. And that's the area of the whole shape. But the problem tells us that that area is 76. So we have 5B plus 21 equals 76. And there are probably lots of different ways to do this. I chose to draw the line here. You could probably also draw it here and figure out what the area is by adding this plus this. But we have an algebraic equation, and we know how to handle those. Subtract 21 from both sides, 55. And so B equals 11. Divide by 5. And the unit is meters. So it says, what is the length across the back of the room? We said, well, we're going to let that be. And then we solved this equation and found B. So the answer, 11 meters across the back. So here's a sphere. Here's the radius inside that sphere. And the volume is 4/3 pi r cubed. It's a formula for the volume of a sphere. All right, so here's one. The radius of a sphere is tripled. By how large a magnitude does the volume increase? All right, so let me draw the bigger sphere. and this one is 3r. So if this one was, say, 4, then the bigger one would have a radius that is tripled. So if r is 4, then 3r would be 12. So the volume of this guy over here is 4/3 pi r cubed, but the radius in this case is 3r. So this is 4/3 pi r cubed, and then we have to cube that 3. So 3r cubed is 3r times 3r times 3r. The 3 times 3 times 3 is 27. The r times r times r is r to the third. So here's the volume of the smaller one, and here's the volume. Now I chose to write it like this because here you see the volume of the smaller one, and you're asked to find a relationship between the bigger sphere and the smaller sphere. So you could say this, you could say that the bigger sphere is 27 times the volume of the smaller sphere. So by how large a magnitude does the volume increase? We would say by a factor of 27. I'm assuming that they're saying that this length is 100 yards, which makes this one. Again, my assumption is that these are indeed, this is a rectangle. I'm also going to assume that this is a half circle and this is a half circle. So when you put it together, you get a whole circle. So the area is equal to the area of the rectangle plus the area of the circle. It's actually 2 semicircles. But those semicircles have the same dimensions. Specifically, if this whole side is 60 and this whole side is also 60, then the radius of the circle we're after is half of that 60, or 30. All right. So the area of the rectangle is length times width, 60 times 100, that's in square yards. And then the area of the circle, what I'm going to do is I'm going to join this half circle with this half circle, making a whole circle. And so the area of a whole circle is pi r squared, and the radius is 30. So 30 squared, again, square yards. So 6,000 square yards plus 30 squared times pi, that many, 2,827. And I'll just round it off to the nearest tenth. So together, add those two together and you get 8827.4 square yards. Now the perimeter is the distance around. So if I start here and move in this direction, I'm going to cover 100 yards. And then I'm going to have half the circumference of the circle. Then I'm going to cover 100 yards again. And then I'm going to have the other half of a circumference of a circle. So this is going to be, and we're not counting these verticals here because these are not actually part of the track out here. 200, 100 plus 100, and then the circumference of the circle, which is 2 pi r. And it's the same radius as we used in the area calculation. That is 388, and we'll just call it 0.5 yards. If Martha and Alyssa run around the track 3 times each, how many miles will they run if their distances are combined? Okay, so 3 times around, there are 2 people, and they're running around, so they're covering this number of yards right here. So the distance equals 3 times around times 2 runners times the length of 1 lap. And that would be yards. This is about 2330. If I do the rounding, all right, so we'll just call it 2331, and that's in yards. But this says how many miles will they run if their distances are combined. And so the next part of this would be to do a unit analysis problem back from chapter 9. And we know that there are 1,760 yards in 1 mile. So we cancel the yards. We're going to divide those numbers, and we'll end up with miles. About 1.3, 2 miles. So just over a mile. Right, so this is a, I don't know, I guess we would call this a triangular prism. So the volume is equal to the area of the base times the height. And so the height is the 9. So we just need to figure out what this base is. There's this base on the top and base on the bottom. There's an intermediate step here, because if you want to find the area, you have to have the base times the height. And the base and the height are perpendicular. So this right angle says that the 4 is the base, and then that missing side is the height. And then once you've figured out what the height is, this missing side, then you could say, well, the area of that triangle is equal to 1/2 base times height. And you're going to have 1 on the top and 1 on the bottom. All right, so since this height falls in this right triangle, we can use the Pythagorean theorem. And just work out the equation. Subtract 16, so you get 8 squared equals 9, so h is equal to 3. So that missing side is 3. And so 1/2 times the base, 4, times the height, 3, 12 divided by 2 is 6. It's a unit of area, so if we did have a unit on there, it would be square units. So the area of the base times the height. 6 times 9. And that's where we get the 64. And then the square units. Okay, the next one, kind of a shape that are built with these 1 by 1 by 1 cubes. So if we just count up the number of cubes, looks like we have 2 layers of those cubes. That's what they lead us to believe. And so you can count them up a lot of different ways. One way would just be to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You have 20 blocks on top and 20 blocks on the bottom. So the volume is 40. And then the surface area, you just have to figure out how many faces that you need to paint. So looking in from this angle, we have 1, 2, 3, 4, 5, 6, 7, 8. We're also going to see 8, have to paint 8 coming in from the other side. So those 8 and the 8 looking in here, that's 16 squares that have to be painted. All right, so now we can look at the down and the up and the down. Here we have the 1, 2, 3, 4, 5, 6. We have the 20 faces here that we have to paint, and that would paint the entire top. But the bottom looks identical to this. There's the same 20 shapes underneath. So 20 and 20 is 40. And top and bottom, okay. And then we have to do this face. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 faces here. And if you come in from back here, you have 12, and you're also going to have 12 coming from the back side. 12 and 12 is 24. So it looks like you're going to have 80 square units. And I think I only ask you to do the volume on this one. And there's just a formula for that. This is the volume of a cylinder, and the volume of the cone with the same radius and height is 1/3 the volume of the cylinder. You can see that the radius is 3 and the height is 10. So this one, it's just about plugging the numbers in and then evaluating. So 1/3 will cancel with one of those 3's, leaving another one. And then so that 3 times 10 is 30, and then you've got the pi, and 30 times pi, if you want the decimal version, is 94 point, we'll just call it 2. It's volume, so this has to be cubic inches, or cubic units, and we don't know that it's inches. Cubic inches, cubic feet, cubic millimeters, whatever. All right, so we want the perimeter here and the area. So if I just go around, this is 1, 2, 3, 4. 1, 2, 3, 4, 5. These other 2 lengths we have to, or other 3 lengths we have to figure out using the Pythagorean theorem. But if I just do area, this rectangle here is 4 by 5. So this rectangle has an area of 20. This length is 2. And this base, 1, 2, 3, 4, 5, 6, 7, is 7. So the area there is 1/2 base times height, and that's 7. So this triangle down here is 7. And then finally, this triangle, 1, 2, 3, 4, 5, and 1, 2, 3. So 1/2 times the base times the height, and that is 7.5. So the total area is 20 for the rectangle, 7 for the triangle down here and 7.5 for the triangle here. So the area is 14.5, 34.5. This one, you're going to have to use the Pythagorean Theorem 3 times. This one here, 3 squared plus 5 squared equals x squared. And I'll call this length x here. This one down here, you have 2 squared plus 2 squared equals y squared. All right, so here's y. That length we're missing. And then over here, we call this z. We have 2 and 1, 2, 3, 4, 5. Okay. So in this triangle here, we have 2 squared plus 5 squared equals z squared. So Pythagorean Theorem 3 times. We still have work to do. We have to solve these equations in each case. In the first one, square root of 34, it's close to 6 because the square root of 36 is 6. Here we have 4 plus 4. All right, so y equals the square root of 8, close to 3 because the square root of 9 is equal to 3. And then this one over here, z equals the square root of 29. So that's somewhere between 5 and 6. So the perimeter is equal to, and just start in one corner, 4 plus the square root of 34 plus y, which is the square root of 8, plus this distance here, z, which is the square root of 29, plus 5. And that's approximately 4 plus 5, square root of 34, square root of 8, square root of 29. So about 23.0 units. Okay, and then this one here, all of the entire shape is made up of vertical line segments and horizontal line segments. So, you know, what you could do is just kind of quadrant it off and just calculate the number of boxes. There's 2 boxes in that region, and that region, and that region, and that region. And then in here, there's 3 by 1, 2, 3, 4, 5, 6. So there's 18 in here. So if you count up all these little areas that enclose the shape, we have 18, 20, 22, 24, 26. So the area is equal to 26 square units. And then if you want the perimeter, you can just walk around. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. And we end at 32. So number of steps we would take all the way around, 32. I don't think for number 13 we have a formula. And so you could just maybe say, okay, it's a shape, and I know how to calculate the shape of a box pretty easily. It's just length times width times height. So what I could do is I could figure out all the different ways that I can get 24 by multiplying 3 numbers together, 3 whole numbers, and then calculate the surface area in each case. So for example, 1 by 1 by 24 would be one box. It's a long, skinny box. It's like the box that those long fluorescent light bulbs come in, 2-foot light bulbs, so 1 by 1 by 24. So length times width times height here would be equal to 24. So that's one way we can get 24. But then we can also get 24 by taking 1 times 12 times 2, or 1 times 3 times 8, or 1 times 4 times 6. These are all different boxes that have different dimensions, but the volume is always the same, 24. All right. If I do 1 and then 6, then I'm back down to 4, so I've got this one. So I think that's the only combinations that will work if the length is 1. All right, let's move up to 2. We can have, I don't want to do by 2 by 1 because I'd get 12. So 2 by 2, that's 4 by 6, that's another one. And 2 by 3, that's 6 by 4, that's another one. Those 3 numbers multiply together to give 24. And let's see, if I go 3 and 3, that's not going to do it. I think this is it. I mean, if we use whole numbers, these are the only boxes that we can construct that would give us a volume of 24. So I'm going to start there. The volume is 24 on all of these, and then just calculate the surface area for each one of these and figure out which one. So this is the volume, and this is the surface area. So this times this is 1 times 2 is 2. This times this is 24 times 2. And this times this is 24 times 2 is 48. And that's too high. All right, let me come down to this one. 1 times 4 is 4 times 2 is 8. 1 times 6 is 6 times 2 is 12. And 4 times 6, 24 times 2 is 48. It's 20, that's 68. Boy, it comes close. So let me try the one right before it. 1 times 3 is 3 times 2 is 6. 1 times 8 is 8 times 2 is 16. And 3 times 8 is 24 times 2 is 48. 22, yep, here's the one. That would work. So kind of trial and error. This wouldn't be a quiz question just because it would take a lot of reasoning through and trial and error problems always take a long time. So.